This is my intermediate algebra course. Today we're going to continue to learn roots. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now in the previous class we reviewed roots, things that we learned in my beginning algebra course, but we combined, we added algebra to the roots. And towards the end of the class, we learned how to rationalize denominators when there's a square root in a denominator. Remember, mathematicians don't like roots in denominators of fractions. And now we're going to keep going with that, but we're going to do more complicated roots. For example, we're going to have something like 2 over root 3 plus 1, and we have to get rid of that root, but the problem is now it's a sum. So we need to learn how to deal with that situation. We've got to get rid of that square root. And it's not as easy as you might think. But before we do that, we have to review some concepts. We're going to review multiplying binomials. And to do that, we're going to use that acronym FOIL. If you took my course, you probably remember FOIL. That means first terms, outside terms, inside terms, and last terms. And if you're coming from a different beginning algebra course, you should have learned this. You probably did, but there's a chance you might not have learned this. So here's what it means. You're going to multiply the first terms, so x times x, and by the way, parentheses means multiplication. So we're multiplying this binomial here by this binomial here. And again, if you're coming from my beginning algebra course, you know this is something you know very, very well. So x times x is x squared, and that was f. We multiplied the first terms. Now we're going to multiply the outside terms. X times negative 5. That would be negative 5x. That was O. Now we're going to do I of FOIL. That's the inside part. That's 2 times x, which would be 2x. And then we're going to do the L part of FOIL, which is the last terms. That's 2 times negative 5 is negative 10. So these are called the first terms because they're the first terms in each binomial. These are called the outside terms because they're at the far left and far right. These are called the inside terms because they're in the middle part. And these are the last terms because they're the second term of each binomial. So now notice that these terms are like terms, and so we have x squared minus 3x minus 10. You can add those like terms in the middle to get the following. So let's do one more of these. We're going to multiply the first terms. 3x times 4x is 12x squared. And now we're going to do 3x times negative 5. That is negative 15x. And then we're going to do the inside terms. Negative 2 times 4x is negative 8x. And then we're going to do the last terms. Negative 2 times negative 5, which is positive 10. And so now we're just going to combine those, and we get negative 23x, combine the inner terms, and there you go. So we could go over this in more detail, but I don't want to bore you because if you're coming from my beginning algebra course, you've done this 1,000 times. You don't really need to practice this that much. Okay, so let's see here. Now it's time for you to try. Go ahead and attempt example number 3, and when you come back, we'll do it together. All right, we're back. Let's see here. So we want x squared plus 8x inside term, or first terms in outside terms, inner terms, and last terms. Then add those up in the middle terms, and we get 17x plus 72. So if you got that answer, good job. Go ahead and try example number 4, and when you come back, we'll do it together. All right, we're back. 6x times 5x is 30x squared. 6x times 3 is 18x. Negative 7 times 5x is negative 35x. And negative 7 times 3 is negative 21. So now all we have to do is combine the like terms, the inner terms. And we get 30x squared and that would be minus 17x minus 21. So if you got that answer, good job. Okay, so now we're going to take that FOIL acronym, that knowledge that we have of multiplying binomials, and we're going to apply it to roots, expression with roots. So we have a binomial here, and we have a binomial here. And we're going to multiply those just like we did before. The only difference is now we have square roots. So it's no big deal, same thing that we did in the last class. So first we're going to multiply the first terms, and I'm going to do this very slowly just to make sure you understand what's going on here. So we multiplied those the first terms. I'm going to skip down a little bit so I can write in there. Now we're going to do O, multiply the outside term. 7 times root 3 is 7 root 3. Then the inside terms, negative 2 times root 3 is negative 2 root 3. And then the outside terms, negative 2 times 7, and you get negative 2 times 7, and there you go. All right, so now we just have to simplify. So now this part here, you recall from my previous class that root A, actually let me write it the way I did in the last class. So that would be root A times B is equal to root A times root B. But you can reverse that. You can write root A times root B is equal to root A times B. And that's the one that we're going to use. So again, if you did your homework, this should be, really, really familiar to you. And it might be a little boring to you because you did so many problems in the last class, but we need to review this. So now this becomes root 3 times 3. And you don't really have to write this step, and you don't have to write this step. I'm just doing this for your benefit. You can skip forward if you want. And that would be 14, right? 2 times 7. And then we're going to turn that to root 9. This is another step that you don't really have to show. I'm going to go ahead and combine those inner terms, plus 5. Let's see here. Well, I might as well just keep the inner terms because I'm going to do one more step anyway. So now we have root 9 is 3. And I'm going to go ahead and combine those inner terms now. So we have 7 apples minus 2 apples is 5 apples. And minus 14, and then the final step. And again, I just want to keep reminding you over and over and over again is that you don't have to show all these steps. I'm just doing this for your benefit. You can skip forward. You can probably skip forward all the way down to here, and then just go directly to the answer. You can do a lot of this in your head. So final answer, 3 minus 14 is negative 11. So we have 5 root 3 minus 11, and that is the final answer. So let's do another one of those. Actually, I think it's time for you to try one of those, actually. So let's go ahead and try example 6. And you can use this principle over here. And when you come back, we'll do it together. All right, we're back. So let me get that out of the way. Multiplying the first terms using FOIL, we have root 6 times root 6. And multiplying the outside terms, we have 4 times root 6. And then the inside terms, we have 2 times root 6. And let me shrink this a little bit. And then the last terms, we have 4 times 2. I'm going to put a little divider here. So now we change that to root 6 times 6. And then I'm going to just go ahead and combine those. And we have 8. And then that would be root 36, which is 6. And then we're ready to add the 6 and the 8. And so 6 plus 8 is 14. And there you go. So again, we're just applying, multiplying roots is something that you already know how to do. We don't have to spend a lot of time reviewing, multiplying roots. You did that in the last class. Very, a lot of problems that I gave you. So now we're ready to go on to the actual point of this. We're going to rationalize two-term denominators. So we have two terms in the denominator, and one of them is a root. We don't like that. We don't like that root there, because that root is going to be a number that is just going to go on and on and on in the denominator. If I go to my calculator and I push 5 and then the square root button, I get 2.2, and I think I demonstrated this in the last class, but it's a good thing to review. So I get 2.236067, and it just keeps going on and on and on and on. So if I try to divide that into something, that huge decimal that goes on forever, if I try to divide that into something, because that's what a fraction is, you're dividing. You're taking 3 and you're dividing it by all this stuff. If I try to do that, it's really almost impossible. And pretty much it is impossible to do that, because the number just goes on and on, the divisor. So that's why we want to get rid of the root in the denominator. So here we go. Let's do it. So right now we're going to learn a trick. And this is going to be something that is, it seems really complicated and just generally tricky. And it's going to seem like this is just, a method that was produced from outer space or something. It's going to seem so weird, but this is just a trick that you use in the math curriculum as you go into upper mathematics, and it's just something that you have to learn. So we're going to do something, like I said, really creative. We're going to take this fraction, we're going to use the fundamental principle of fractions, and we're going to, I'm going to have to put that in parentheses, we're going to have to multiply both sides of the fraction by 4 minus root 5. See, the denominator is 4 plus root 5. We have to multiply by 4 minus root 5. That's the trick. And you're probably thinking, why in the world are we doing that? Well, what you're going to find is that when we multiply these two, that root is going to go away. And that's the whole point. So, and it's extremely important to understand we're using the fundamental principle of fractions. That means you can multiply both sides of the fraction by the same number. We're multiplying by 4 minus root 5, and we're multiplying the bottom by 4 minus root 5. So it's the same number. So that means that the fraction is going to remain equivalent. In other words, it's not going to change the value of the fraction. So now we're going to go ahead and put that together. We don't really need this step where we put it together, but I just want you to be absolutely sure what exactly we're doing. So that's what it reduces to. All right, so now we're just going to use distribution. 3 times 4 and 3 times negative root 5. So 3 times 4 is 12. And 3 times negative root 5 is negative 3 root 5. And now in the bottom we have to use FOIL because we're multiplying two binomials. So that's why we had to review all that FOIL stuff. So now 4 times 4 is 16. 4 times negative root 5 is negative 4 root 5. Root 5 times 4 is 4 root 5. And root 5 times root 5 is or root 5 times negative root 5 is negative root 5 times root 5. I guess I can just write it out. Again, we're going real slow here just to be absolutely sure that you know what's going on. But I just want you to be aware you can skip through a lot of these steps. You don't have to write root 5 times root 5. And notice I didn't write a dot in between those roots. You don't really have to. So now we have 12 minus 3 root 5 over 16. And here's where the magic happens. You ready for this? This is why we did this. Here we have negative 4 root 5. Here we have positive 4 root 5. Those are going to cancel out when you add them together. And you're just going to be left with root 5 times 5. Because remember, we're using that principle. Let me get it over here. you're just combining those. See this principle over here? When you're multiplying those roots, you can just put them inside, put the product inside. So now we have 12 minus 3 root 5 over 16 minus root 25. But root 25, that's just 5. So then we have 12 minus 3 root 5 over 16 minus 5. And we're almost there. So we have 12 minus 3 root 5 over 16 minus 5 is 11. And there you go. That's the final answer. So we got the, and you might be thinking, I don't get the point of that. Why do we do all that crazy stuff? Well, we did it because we have to, again, get rid of the root in the denominator. Mathematicians don't like that root in the denominator. It's called rationalizing the denominator. And so here we had a denominator with a root. Now we have a denominator with no root. So that's the whole point of this. It's very important to understand what we're doing and why. So let's try number 2. And in number 2 we have 2 roots, but it's going to be the same procedure. So we're going to rewrite. And we're going to multiply both sides of the fraction by root 3 plus root 7, because the denominator is root 3 minus root 7. Now we're going to, 1 times any number is just the number itself. So we're just going to end up with root 3 plus root 7 in the numerator. And in the denominator, let me extend this out a little bit. In the denominator, we're going to get root 3 times root 3. That's f of FOIL. And then O of FOIL is root 3 times root 7. And then I of FOIL is negative root 7 times root 3. And then L of FOIL is negative root 7 times root 7, and you get negative root 7 times root 7. Whoops. And so now we just have to simplify the denominator. And so root 3 times root 3, you can just use that principle. Remember, if you flip the equation, root a times root b is equal to root a times b. If you flip that equation that we went over in the last class, so at the bottom is just going to be root 3 times 3, and then you could just cancel these out immediately. We don't really have to multiply them, but let's just multiply them so you can see what's going on here. So they combine to one root, and same thing with the 7s at the far bottom right. So now we have root 3 plus root 7 in the numerator. Again, there's not much we can do with that. Root 3 times 3 is root 9. And then we get root 21 minus root 21 minus root 49. So again, we're just continuing to simplify here. Again, we can't do anything with the numerator. Square root of 9, what number times itself is equal to 9? Well, that's just going to be 3. And these terms, it's very important to understand that these terms just cancel out, because one is positive and the other is negative, and that's why we did this. That's why it works. And what number times itself is equal to 49? Well, that's 7. And so, as you can see, we got rid of the roots in the denominator, and that's the whole point of this. We're rationalizing the denominator. So now 3 minus 7 is negative 4, and there you go. So that is the final answer. Now you can take that negative and put it up in the numerator then it would be negative root 3 minus root 7 over 4, but you can just leave it like that. That's probably best. Alright, so now it's time for you to try one of those. You're going to want to get a screenshot of these so you can refer back to these if you need to. And so let's go to the next problem, and it's time for you to try. Try number 3. What you're going to do, again, you're going to rewrite it for one thing. You need to show what you're doing. You don't have to show every single step, but you're going to multiply by, well, you probably know. So go ahead and try number 3. The whole point is to get rid of that root in the denominator. So go ahead and try number 3, and when you come back, we'll do it together. All right, we're back. We're going to multiply by 9 plus root 2 because the denominator is 9 minus root 2. So then I'm just going to, well, I'm tempted to skip forward through this stuff, but it's probably best to just show every step here. And now we're going to distribute 8 times 9 and 8 times root 3. That's called the distributed property, if you forgot that. So we have 72 plus 8 root 2. And now we're going to use FOIL. F of FOIL is 9 times 9 is 81. And the outside terms of FOIL is 9 root 2, so plus 9 root 2. The inside is negative root 2 times 9, so we have negative 9 root 2. In case you're wondering, the coefficient, the root is almost always written second. That just avoids confusion. You could write root 2 and then 9, but the problem is sometimes people write it too close and it looks like 29 or it looks like it's inside the root. You really want to avoid that. Okay, so and then we do negative root 2 times root 2. And there you go. So I just want to simplify that. There's nothing we can do in the numerator. We have 81, and the inside terms cancel out, and then we get root 2 times 2. And we have 81 minus root 4, and you can see where we're going with this. That root 4 is going to disappear. And you might wonder, where did people come up with this method? This is kind of advanced stuff here. Well, people basically they think about it for a long time, and they come up with this creative way to get rid of that root. Nobody knows exactly who thought of this, at least I don't think people do. So 81 minus 2 is 79. And there we go. So if you got that answer, good job. Now, if this were 78, then we'd have a problem because we'd have to keep going and reduce that fraction. But thankfully, the 79, I don't think it has any common factors. At least I don't believe. Okay, so if you got that answer, good job. Go ahead and try number 4. And when you come back, we'll do it together. All right, we're back. So now we have 2 roots, but it's the same principle, same process. We're going to multiply both sides of the fraction by root 7 minus root 5. And so I'm just going to go ahead and use distribution. 10 root 7 minus 10 root 5. And in the bottom, we have root 7 times root 7, root 7 times negative root 5, and root 5 times root 7, and root 5 times negative root 5 is negative root 5 times root 5. And it's nice to have your numerator right in the center. It just kind of ends up drifting off there. Okay, so there's nothing we can really do in the numerator. Just have to keep that there. You might think, well, aren't these like terms? Can't you just subtract those? Well, no, because you're dealing with apples and oranges. You have 10 apples and you have 10 oranges. You can't add apples and oranges and make it one number or subtract them. So now we have root 49, and the magic happens right here. You know, I didn't mention this, but these terms, you know, they're going to cancel out, so you don't even have to write them really. But I'm just going to write them just so you know what's going on here. So we have 7. Oh, whoops, I kind of jumped forward there a little bit. Sorry about that. That's 7 times 7. 7 times 5. 7 times 5 again, and 5 times 5. Again, you don't have to show all this. We're just doing this so you can see every single step. Students tend to get pretty confused when it comes to roots because this stuff is not intuitive at all. Then we go root 49 minus root 35 plus root 35 plus root 25. I'm sorry my numerator keeps drifting over like that. It's just the nature of the problem. Okay, so again, we're going to rewrite the numerator. And you might be thinking, well, if I don't have to show every single step, how many steps do I have to show? Well, you have to show maybe 2 steps, maybe 3 at the most. As you can see, I have 1, 2, 3, 4, 5 steps, and I'm probably even going to go to more. So now these two cancel out. You can see they're opposite terms. When you add them together, they cancel out. And root 25 is just 5. So now we have 7 plus 5 in the... wait a second. No, I'm sorry. I'm sorry about that. Made a mistake there. That should be minus 5. So 7 minus 5. Then we have 7 minus 5 is 2. Now at this point, you can actually keep going. If you got this answer, then that's perfect. You did perfect. There's no problem whatsoever. But I just want to let you know that you need to keep going with this. Okay? If you forgot how to do this from my beginning algebra course, that's okay. But see how you have tens here in both terms? If you have tens or anything that's a multiple of 2, you can, or if anything that has a factor of 2, you can reduce it. So you can just divide both these terms by 2. 10 divided by 2 is 5, so it's 5 root 7. And again, 5 in the other term, and so the fraction actually goes away. That's not going to happen in most of these problems, but it will happen in some. So again, if you got this answer, that's fine, but go ahead and go one more step and write the final answer. Okay, so we're going to do a few more of these problems. This problem is different because we have a binomial in the denominator, but we also have a binomial in the numerator. So, but there's nothing really different about, the technique to get rid of the root in the denominator. Remember, we're trying to get rid of the root in the denominator. We don't care about roots in the numerator. Okay, so what you're going to do is you got to put parentheses on both these because remember that there's that problem. And we're going to multiply by root 2 minus 3. Both sides by root 2 minus 3. Okay, and again, the denominator determines what we're multiplying by because we're trying to get rid of the root in the denominator. So now we're going to use FOIL on both of these. Okay, root 6 minus 5 times root 2 minus 3. That's going to be our numerator. And our denominator is going to be root 2 plus 3 times root 2 minus 3. All right, so let's get going. And at this point, I'm not going to show every single step because this is going to get really boring if I do this every single time, especially with such a long problem. So we need to start skipping forward. So root 6 times root 2 is root 12. Root 6 times negative 3 is negative 3 root 6. Negative 5 times root 2 is negative 5 root 2. And negative 5 times negative 3 is positive 15. So this is more towards what you would actually do if you were, attempting this problem. You don't have to show every step. Root 2 times root 2 is root 4. Root 2 times negative 3 is negative 3 root 2. 3 times root 2 is 3 root 2. And 3 times negative 3 is negative 9. So now all we have to do is simplify. Now, here we have a perfect square inside there, so we're going to have to pull out the perfect square. So that's 4 times 3. And we can't really simplify these terms because it's apples and oranges. We can't add a root 6 and a root 5 or subtract them. So there's nothing we can really do in the numerator other than pull out the perfect square. Now, root 4, that's going to be 2. These two terms are going to cancel out, and you have 2 minus 9. So we got rid of the root in the denominator. Now all we have to do is try to simplify this as much as we can. So we're going to pull out the perfect square. So that's root 4 times root 3. First we have to separate. And in the denominator, we can go ahead and subtract 9 from 2, and we get negative 7. Now, root 4 becomes 2, and you can just put the root 3 next to it. And again, this principle here, where we took out the perfect square from here, that's what we learned in the previous class. We're just reviewing it. So at that point, we don't have any like terms. We have, root 3, which is like an apple, and we have root 6, which is like an orange, and then we have root 2, which is like a lemon. So we can't combine those because we can't combine them into one number. So at this point, we're kind of done. But remember, you can take that negative and you can put it up. I'm not going to show every step of that, but basically all that means is that all the signs up there are going to change. And I changed the order of the terms a little bit. And the bottom is going to change to positive. So notice how I wrote the positive terms first. We just like writing those positive terms first. You can do it the other way. But notice how every sign changed. So that is that problem. And so now for number 6, we have the same situation. So why don't you try number 6, and when you come back, we'll do it together. All right, we're back. So we're going to rewrite. And remember, the denominator determines everything. So the denominator is 5 minus root 10, so we're going to multiply by 5 plus root 10. And so we get, if we FOIL the top, we get root 35. Oh, excuse me, not root 35. Root 7 times 5 is 5 root 7. And root 7 times root 10 is root 70. Again, I'm skipping forward here. I'm not showing every step now because we just don't have time to show every single step, but we don't really need to show every single step at this point. You should get the idea. So I used FOIL in the top. That looks correct. Just double checking. And now 5 times 5 in the bottom is 25. And 5 times root 10 is 5 root 10. And negative root 10 times 5 is negative 5 root 10. And negative root 10 times root 10 is negative root 100. And there you go. So now the top, as in the previous problem, you can't really do much with the top. So we'll just rewrite that. Now 70, you might think, can we pull a perfect square out of 70? No, you cannot. There's no perfect square factor in 70. In the previous problem, we pulled out a perfect square over here. You see that? 12 had a perfect square, but 70 does not. All right, so in the bottom, these terms cancel out, and we're left with 25 minus root 100. And root 100 is, that's what number times itself is equal to 100? Well, that would just be 10. So now we're left with the final answer, 5 root 7 plus root 70 plus 15 plus 3 root 10 all over 15, it looks like. So if you got that answer, good job. Okay, we're going to do 2 more of these problems. These problems, there are roots in every term. So now we're going to really get crazy with the roots. But we're going to use the same technique to get. We're trying to get rid of 2 roots in the denominator, 2 of them. You know, in the previous problems, we only had 1 root. At least I think so. Yeah, we only had 1 root in all those other problems in the denominators. Actually, no, I take that back. In this problem, we had 2 roots in 2 of those problems. But now we have 2 roots in the bottom and 2 roots in the top. But it's the same technique. So we're going to multiply both sides. The denominator decides everything. So it's plus root 7. And so we're going to foil the top. We get 2 root 6 plus root 14 plus 2 root 18, and we have a perfect square in that 18. We're going to have to deal with that, plus root 42. Again, I'm skipping forward on, I'm not showing the actual formula that we're using. In the bottom, we multiply, we get 4 root 9, and then plus 2 root 21, and then minus 2 root 21, and then minus root 49. And so on the top, those are all unlike terms, so there's not really much we can do except pull out that perfect square from the 18. So that's 9 times 2. And that 9 is going to come out as a 2, or excuse me, as a 3. So now these terms cancel out, and root 9 is just 3, and root 49 is 7. What number times itself is equal to 49? 7. And I should probably put parentheses around that. Remember, you have to follow order of operations in the denominator. So now 2 root 6 plus root 14 plus 2 times root 9 times root 2. We use that principle where we pulled apart the root. Remember, we learned that in a previous class. And the bottom, we have 12 minus 7. And we're almost done with this problem. Root 9 is 3. Twelve minus 7 is 5. Now I know this seems long, but again, you can skip a lot of these steps. So now our final answer is 2 root 6 plus root 14 plus 6 root 2 plus root 42 all over 5. So I just want to be absolutely sure that you know how to use this technique. It is a technique that you're expected to know when you go into upper mathematics. Okay, so on to the next problem. I want you to go ahead and try number 8, and when you come back, we'll do it together. All right, we're back. So, as usual, we're going to rewrite and multiply both sides by root 2 plus root 3. And so we have root 20 plus root 30 minus 3 root 10 minus 3 root 15. And then we have root 4 plus root 6 minus root 6 minus root 9. And at the top, we can't really do much except pull out a perfect square out of that 20. And root 4 is 2. These inner terms cancel out. We have minus root 9, which is 3. We move that over. And so we're left with root 4 times root 5 plus root 30 minus 3 root 10. And I'm sorry, I keep running out of room here. It's hard to fit all this stuff on the page, and we get negative 1. So we definitely want to, keep going one more step here. And don't worry, I'm going to put a divider here. Because we can, if we go one more step, we can actually just get rid of that fraction altogether. So let's put a divider. So you divide by 1, nothing changes, but because it's negative, that just means all the signs up here are going to change. So first, let's find the square root of 4 is 2, and I'm just going to change that sign to negative, change this sign to negative, change that sign to positive, and change that sign to positive. And that should be your final answer. Now, if you got the previous expression, if you got this expression here, then that's completely fine. But you do need to keep going down here. So that should be your final answer. But if you got this expression, then you did it 100% correct. So if you got that answer, good job. So that was rationalizing denominators that have two terms, rationalizing two-term denominators. So again, I know that was a nasty trick to have to do with that complicated denominator, but the rest of the problems today are going to be a lot easier. So now we're going to rationalize algebraic fractions. We're going to rationalize denominators, but the difference here is that now we have algebra. In the previous class, we had all kinds of fractions. For example, we would have a fraction like 3 over root 5, and we'd have to rationalize the denominator by multiplying by root 5, multiplying both sides. Then we get root 25, and then we get 3 root 5 over 5. I skipped one step there. But now we have algebra, and so it's going to be the same process though. So now we're going to rewrite, and we want to get rid of that root in the denominator, so as you can imagine, we're just going to multiply by the denominator. And in the top, nothing really happens, so we just get 3 root 5x. And the bottom, we have root 5x times 5x. And again, you can probably skip forward at this point, but that would be root 25x squared. So what you can do is you can pretty much go from this point all the way down to the very end if you want. You don't have to show all this work. And now we have 3 root 5x over root 25 times root x squared. And that becomes 5 times x. Or we can just put 5x and then you're done. So this is pretty much the same thing you were doing in the previous class, except now we have algebra in these fractions. Okay, so let's try one more of those. Again, we have to get rid of that root in the denominator. So we're going to multiply both sides by root 3x, and we get 2x times root 3x, and in the bottom we have 7. And you know, the reason that I'm telling you to skip forward is because when you multiply these roots, they just go away. You just end up with 3x. You know, and so at this point, I think I'm going to just do that. You know, we're not going to show that step anymore because it's pointless. You always, if you notice, so you multiply root 5x times root 5x, you just get 5x. So I think we've gone far enough, you know, to where you get the point. And I now need to, I need you to understand that you don't really need to show all that. So root 3x times root 3x is just 3x. And we just have one more step at that point. 2x times root 3x. So a lot of students might say, well, why don't you just keep showing every single step? Well, because you don't need to do every single step. You know, if you get the idea that you have to show every single step of that, then when you actually do these problems and you have to do them quickly, you're going to be doing all this, and you know, it's just not going to be efficient. So that is the answer. Now it's time for you to try. I'm going to put some dividers here, so go ahead and try number 11, and when you come back, we'll do it together. All right, we're back. So we're going to rewrite. Multiply both sides by root x, and we have 8 root x over x, and that's it. Now again, you may have showed more steps than that, but you don't really need to at this point. So now go ahead and try number 12, and when you come back, we'll do it together. All right, we're back. So rewrite. And we're going to multiply both sides by root 10x. And then we get negative 9x squared root 10x all over 5. And again, that just becomes 10x. When you multiply a root by itself, it just gets rid of the root. So now we have negative 9x squared root 10x over 50x. 5 times 10x is 50x. And that is the solution. So if you got that answer, good job. If you didn't get that answer, that's okay. Just go back and figure out what you did wrong. Oh, whoops. I'm sorry, I forgot to do something here. We can actually cancel out the x's. If you didn't do that, that's okay, because we haven't done one of these yet. See how there's an x squared in the top and an x in the bottom? Those are factors that are common. So that would become negative 9x root 10x all over 50. So one of the x's here cancels out, and it reduces to just x. Why? Because there's an x down here. Remember, x divided by x is just 1. They disappear. So that's pre-algebra stuff. That's beginning algebra stuff, so on and so forth. Okay, on to the next problem. So this problem is a little different because there's perfect square factors down here. So we have two problems. One problem is we have a root in the denominator, and another problem is that we have a perfect square factor inside the root. So we're going to have to take care of both of those problems. So first I'm going to take care of the perfect square factors in the root. So I'm going to factor that to 4 times 2, and then x squared times x. All right, so then we have negative 2 on the top, and 7 times root 4 times root 2 times root x squared times root x. Then we have negative 2 over 7 times 2 times root 2 times x times root x. At that point, we can just combine. 7 times 2 is 14. Whoops, I got to put the numerator. 7 times 2 is 14. Then we can put the x. Everything outside the root goes together, and then everything inside the root, you can just put it back together. Again, that's going in the backwards direction, taking two roots and combining them. So at this point, we have one more thing we can do. We can reduce negative 2 over 14, so that becomes negative 1 over 7x root 2x. The first problem was that we had a perfect square factor and a root in the denominator. So we took care of that problem. We pulled out the perfect square. But the second problem is that we have a root in the denominator, so now we have to take care of that. So we're going to multiply. First rewrite though. We're going to multiply both sides of the fraction by root 2x. And then we get negative root 2x over 7x. And again, root 2x times root 2x is just going to be 2x. So now we're almost done. We have negative root 2x over 14x squared. And it's traditional to put the negative sign, write it so it's level with the fraction line. Okay, so again, we had two problems. We had a perfect square root inside the denominator, and we had the root in the denominator itself. So try number 14. You got to take care of both those problems. And when you come back, we'll do it together. All right, we're back. So we're going to pull out that perfect square factor. That's 9 times 2. And then, actually, x to the fourth is already a perfect square, so we don't have to worry about that. And so now we're going to separate the roots based on that rule we learned in the previous class, actually my beginning algebra course. And simplifying. And then, these we can actually just cancel out immediately, or, we can reduce them, but I'm just going to keep them there. So we have 15x squared root 2. So remember how I could have done 6 divided by 3 is 2. But I didn't do that. So the problem is now I have a fraction that's not reduced. So we're going to divide both of those numbers by 2, and we get, both of those numbers by 3, and then we get 2 over 5x squared root 2. So, we had to reduce. Again, we reduced with the problem up here. So, if you forgot to reduce, that's okay, but that's something that you really need to do. So now our problem is that we have a root in the denominator, so we're going to have to rewrite that and multiply both sides by root 2. So we have 2 root 2 over 5x squared times 2. And you can use parentheses or dots, however you want to do that. Again, root 2 times root 2 is just 2. And so now we have 2 root 2 over 10x squared. And I'm sorry I did this to you, but we're going to have to reduce again. If you got that answer, that's 100% correct. There's nothing wrong with it whatsoever. But you do have to reduce your fractions. So 2 over 10 reduces to 1 over 5. We don't have to put a 1 in the denominator. But there we go. Now again, if you didn't get the exact same answer, that's okay. I'm sorry I threw a curveball in there with all that reducing, but that's something you're going to have to get used to. All right, so now we have a problem where we're square rooting the entire fraction. So remember the rule, square root of a over b is equal to square root a over square root b. That's a very important one that we're going to use over and over again in the next problems. So I'm going to move this up here. So then we get square root 5 over square root 81 x to the 6th. And now we're going to use the basic principle again in the denominator. We can just separate that into two roots. we don't really need to separate it. We can just square root it immediately. We can kind of see what's going on there. And then we have root 5 over square root of 81 is just 9 square root of x to the 6th power. Remember, you just divide the power in half. That's what we did in the previous class. So that would be x to the 3rd power. Because it's even, it makes it really easy. You just divide the power in half. So now we have root 5 over 9x cubed, and we're done because there's no root in the denominator. And there's no perfect square inside the root. So that was a pretty easy one. The next one is going to be just as easy because this is a perfect square here. Let's go ahead and try number 16, and when you come back, we'll do it together. All right, we're back. So we have root 11 over root 36x squared. And we have root 36 times root x squared. Root 11 over 6 times x. Root x squared is just x. And finally, root 11 over 6x. So if you got that answer, good job. So for number 17, the perfect square is going to happen in the numerator, but we're going to use this same principle up here. So that would be root 49 over root 2x. Root 49, that's a perfect square, so that just becomes 7. But now we have a problem because there's a root in the denominator. So we're going to have to get rid of that root in the denominator, but that's okay because that's what we did in the previous problems. And then we get 7 root 2x. And again, I'm just skipping forward here. Root 2x times root 2x is just 2x. You know, whenever you multiply a root by the same root, you just get rid of the root. As long as it's a square root, you're going to find that's not necessarily true with other roots, but with a square root, that's true. So I want you to try, you can get a screenshot of that if you need to, because we're going on to the next page. I want you to try number 18. It's going to be the same type of thing, because 25 is a perfect square, but then after you square root both sides of the fraction with that principle, you're going to then need to get rid of the root in the denominator. So we're using that principle. Try number 18, and when you come back, we'll do it together. All right, we're back. So using that principle again up there, we have root 25 over root 7x, which is just 5 over root 7x. Now we have a root in the denominator. So we have to multiply both sides of the fraction by root 7x, because that's going to get rid of the root. And then we have 5 root 7x over 7x, and we're done. Again, I'm skipping a lot of steps there because it's okay to skip the steps. You don't want to keep doing every one of those steps like we did in the previous problems in the previous classes, because then it's just going to become ridiculously long. At some point, you have to reach a level of math where you start to skip forward through the things that you have done a billion times and you already know how to do. Okay, so let's do number 19 together. Now, notice on number 19, neither the numerator or the denominator has any perfect squares. So you just use that principle up there. We're going to root the numerator and the denominator, and then you just get rid of the root in the denominator, and we end up with now this here, those are both roots, so you can again just multiply the inside. So that would just be root, and maybe I should just write that, so that'd be root 5 times 6x. You can just write root 30 if you want, but and the bottom is just going to be 6x. Again, the roots just make each other disappear when you multiply them. So final answer is root 30x over 6x. And there you go. So now it's time for you to try one of those. Go ahead and try number 20. And when you come back, we'll do it together. All right, we're back. So we're going to use that principle up there on the left. I'm trying to keep that in the window. And then we're going to rationalize the denominator by multiplying both sides by root 7. And then we get root 14x. Again, I'm skipping a little step there because if they're roots, you can just multiply the inner parts. And then root 7 times root 7 is just 7. And you're done. Now, a lot of students would say, hey, I can reduce this. Actually, you can't. If you got fooled by that, that's okay. It's not going to be 2x or root 2x. And the reason you can't do 14 divided by 7 is that, the 14 is inside a root, so it's not the same thing as 14. So if you got fooled by that, that's okay. Just go back and write this as your answer. Okay, so if you got that answer, good job. On to 21. Now, number 21, there's a perfect square inside the numerator, so we're going to have to deal with that. But first, we're going to use that basic principle. We're going to square root the numerator and the denominator. Then I'm going to pull out the perfect square in the numerator first, and I'm going to deal with the root and the denominator later. So that's going to be 25 times 2 times x, and I have to pull out the perfect square inside the x's also. So that's why I factored that. So now we're going to separate using the same principles we used in previous classes. So root 25 is 5, and root x to the 6, you just divide the power by 2 because it's an even power. And so now we're going to put the 5 and the x cubed together. We have 5x cubed, and put everything in the root back together. Again, we've done this before. A lot of this stuff is just the same thing we were doing in the previous class. So now we took care of the perfect square factor in the numerator. But now we have a root in the denominator. We have to take care of that problem. So we're going to multiply both sides by root 13. And we get 5x cubed, and we can just multiply those. That's 26x. Again, skipping forward, and that is the final answer. So each one of these problems is different. A lot of students might say, how come we keep doing the same problem? These are not the same problem. Each one of these has minor differences. And the key to learning math is repetition, repetition. You won't learn it without repetition. It's not possible. So go ahead and try number 22, and when you come back, we'll do it together. All right, we're back. So we have a perfect square in the numerator. We're going to have to deal with that. Multiple perfect square factors. So then we're going to factor, that's going to be 16 times 2, and then x to the 4th times x. We're going to have to factor out an x there, or peel off an x, however you want to describe it. And we're going to separate. And root 16 is 4. Root x to the 4th is x squared. Then we have all the numbers outside of the root, put them together, and then all the numbers inside of the root, put them together. So we pulled out the perfect square factor in the numerator. So at this point, we need to get rid of the root in the denominator. Now, I wish I could show you everything all at once, but that just makes things hard to see, so I really need to zoom in here. So we're going to multiply by root 7, because that's the denominator. And so we get 4x squared times root 14x. And then on the bottom we have 7, and that's the final answer. again, we can just skip forward here. Root 7 times root 7 is just 7. That's it. So, if you got that answer, good job. So now we're going to try a problem that's exactly the same as the previous problems, except it has a perfect square factor in the denominator rather than the numerator. And I'm going to put a divider on all these. So, but it's going to be the same procedure for the most part. So we have root 10 over root 9 times 3 times x squared times x. Again, we're getting rid of the perfect square factors in the denominator, so now we have root 9 times root 3 times root x squared times root x. And just moving that over. And we have root 10 over 3 times root 3 times x times root x. This is all stuff that you should be familiar with because of the previous class. If you don't recognize this stuff at all, that's probably because you didn't do the homework in the previous class. So now we have root 10 over 3x times root 3x. Put everything in the roots back together, and everything outside the roots, you can put them next to each other. So now we got rid of that perfect square factor in the denominator, but now we have to deal with the issue of the root in the denominator. So multiply both sides by root 3x to get rid of that root in the denominator. And root 10 times root 3x is root 30x. And then we have 3x, and then these just make the root go away, and you're left with 3x. So now we have root 30x over 3x times 3x is 9x squared, and we're done. So again, that was a problem where the square root, or the perfect square, was in the denominator. So I'm going to leave that in the window. I want you to try, actually we can't leave that in the window. You might want to take a screenshot of that so you can use that. Or you can just try it without the screenshot. So try number 24, and when you come back, we'll do it together. All right, we're back. So root 3 over root 28x to the 10th. And we're going to factor to 4 times 7 times x to the 10th. X to the 10th doesn't have to be factored, it's an even power. And root 3 over root 4 times root 7 times root x to the 10th. And root 4 is 2. And root x to the 10th is x to the 5th. Remember, you just divide the powers by 2. If you can, if they're even. That's even, so we can divide it by 2. If they're odd, you have to factor out a perfect square. So now we have 2x to the 5th root 7. And again, you might think, well, we're done at that point. But the problem is we have a root in the denominator. We took out the perfect square root in the denominator, but we still have a root in the denominator. So we're going to have to use that, or we're going to have to rationalize it. So times root 7 times root 7, and we have root 21 over 2x to the 5th times 7, because those roots, when you multiply them, they just become 7. When you multiply these, they just become 7. That's what multiplying a root by a root does. Okay, so now we have root 21 over 14x to the 5th. And that is the final answer. So if you got that one right, good job. All right, number 25. Let's do this one together. So now we have perfect square factors in both the numerator and the denominator. So each of these problems is getting a little bit harder. So now we're going to factor the numerator. It's going to be 4 times 2 times x squared. We don't really need to factor the x squared. That's an even power. And this is going to be 9 times 3. So now we separate root 4 times root 2 times root x squared all over root 9 times root 3. Root 4 is just 2, and that's going to be x. That's going to be 3. Combine everything. We have 2x root 2 over 3 root 3. And everything looks good, but the problem is we have a root in the denominator. So now we're going to have to rewrite that and multiply both sides by root 3. And we get 2x root 6 over 3 times 3, because root 3 times root 3 is just 3. And we have 2x root 6 over 9, and that is the final answer. Okay, so I want you to try one of those. You can use 25 to help you. And when you come back, we'll do it together. All right, we're back. So using the principle where we can root the denominator and the numerator. And then that becomes root 9 times 5 over root 4 times 11 times root squared times x. We have to take out the factor of the x cubed also. So then we have root 9 times root 5 over root 4 times root 11 times root x squared times root x. And at that point, square root of 9 is 3. Square root of 4 is 2. Square root of x squared is x. And we have 3 root 5 over 2x times root 11x. And now we have to get rid of that root in the denominator. So we're going to multiply both sides by 11x. And we get 3 root 55x over 2x times 11x. And then we have 3 root 55x over, sorry about that, I don't know why it's doing that. 2x times 11x is 22x squared. And that is the final answer. So if you got that answer, good job. Oh, all right, on to 27. Now these problems are going to be a lot easier. So these are the problems that we didn't really do at all in my beginning algebra course, but in this course I wanted to cover these. So here you're going to go backwards. So I'm going to get that formula. Where'd that formula go? Somewhere up there. It is up there. I'm going to take this formula, bring it down here. So remember, we went from left to right on that formula, but now we're going to reverse it. We're going to go backwards. So we're going to take root a over root b, and we're going to combine it to one root. So why would we want to do that? Isn't that going backwards? Well, in these particular problems, it's going to work for us. It's going to make the problem a lot easier in this particular problem. That's not the case in every problem. In fact, all the problems that we were doing so far, this wouldn't work. So again, we just went backwards in this formula. And now the reason we did that is because look what happens. We can actually reduce this fraction. 3 over 27 reduces to 1 over 9, and x to the 5th over x to the 3rd power equals x to the 2nd power. Now, I don't want to write 1x squared over 9, because, again, 1 is not written as a coefficient. If it's, it's just not necessary. So at this point, things get even better, because now we can go in the opposite direction, the reverse direction, and separate it again. So now we get root x squared over root 9, which just ends up being x over 3. So all of that stuff reduced to just x over 3. So this is something that you can use if you need to. So go ahead and try number 28, and it's the same principle. And when you come back, we'll do it together. All right, we're back. So we have root 8x over 2x to the 5th. And we're going to reduce that. 8 over 2 is just 4. And the x's cancel, and you end up with 4 x's in the bottom. And you might say, well, I don't know how to do that. How do I get 4 x's in the bottom? Well, that's just pre-algebra review. And beginning algebra review. We did that pre-algebra, beginning algebra. If you forgot, that's okay, but that's really what you need to do. So now, again, we have a great situation here because those are both perfect squares. So if we go in the reverse direction, we just have 2 over x squared, and there you go. So those were pretty easy. So the last problems that we're going to do are problems where you're going to have to rationalize a two-term denominator with a variable. And this is not going to be any more difficult really than the problems that we did at the beginning of the class. So you want to get rid of that root, but it's a two-term denominator. So same situation, you're just going to multiply by root x plus 7. And then we can distribute. We get 4 times root x plus 4 times 7 is 28. And then root x times root x is root x squared. And, again, you don't really have to write root x squared. You can just write x because that's what it's going to be. But I'm just going to write root x squared in these first problems so you don't, so you know exactly what I'm doing. So in the last term, again, we're using FOIL. The last term is going to be negative 49. So we have 4 root x plus 28 all over x. These terms cancel out, and that's why we did that. And you're left with x minus 49. So why did we do that? Well, because again, we wanted to simplify wanted to rationalize the denominator. Okay, on to number 30. We have really 3 more of these problems, and you might want to take a screenshot of that because you're going to use that in the next problem. You're going to use that what we did there. So I want you to try number 30. You're going to rationalize that denominator by multiplying both sides by root 3 minus 2. So go ahead and try that problem, and when you come back, we'll do it together. All right, we're back. So we have 6 over root 3x plus 2, multiplying by root 3x minus 2. So we have 6 root 3x minus 12, and root 3x times root 3x. There's a lot of different ways you can do it. You can write it as root 9x squared, or you can just write it as 3x because it's going to simplify to 3x. Then we have negative 2 root 3x plus 2 root 3x minus 4. Again, sorry, my numerator is floating around there. And so we have 6 root 3x minus 12. And again, this is just going to simplify to 3x. We don't really have to show all that. At some point, you got to just, learn how to jump forward there. These are going to cancel out, and we're left with minus 4. And so that is the answer. You can't really reduce much beyond that. We can center this denominator just to make it look nice and neat. Okay, so if you got that answer, good job. So let's go ahead and try, let's do 31 together. So 31, again, we just have algebra, and we have a root in the denominator, but the difference is we have a binomial in the numerator. In the previous problem, we didn't have a binomial in the numerator. So let's put a divider here. So same principle, same thing we've been doing pretty much for the whole class. Going to get rid of that root in the denominator, but be sure to put parentheses on both the numerator and the denominator when you do this, or else what you're writing is not going to make sense algebraically. Even if you can do it correctly in your head, that doesn't matter. The most important thing in this course is knowing how to read and write the language of algebra, and that's why we're writing all this down. So now we're going to FOIL in the top, and we get root 10x. Minus root 2 minus 3 root 5x plus 3. In the bottom, we just get root 25x squared, but that's just going to end up being 5x. So I'm just going to jump forward on this stuff. And minus root 5x plus root 5x minus 1. And in the numerator, it looks like we can't really do anything. And the inner terms cancel out, and you're left with 5x minus 1. So I'll go ahead and try 32. That's going to be the last problem for today, and when you come back, we'll do it together. All right, we're back. So we're going to rewrite, and we're going to get rid of that root in the denominator by multiplying by root x minus 9 and root x minus 9. And then we're going to FOIL the top, so we have root 6x squared, and now we have a perfect square in there. So that's a little different there. And minus 9 root 6x minus 2 root x, and then plus 18. FOIL the bottom, we have root x times root x, so the roots just go away. Minus 9 root x plus 9 root x, and then minus 81. And here we have a perfect square factor, so we can separate that, root 6 times root x squared. And I'm going to make more room here as we go. And the bottom, we have the inner terms cancel out, and you're just left with x minus 81. And we just have to square root that x squared, and we're going to get root 6 times x, and I'm just going to put that x right in front. I don't want to rewrite that whole thing again. So x times root 6 minus 9 root 6x minus 2 root x plus 18 all over x minus 81, and that is the answers. So if you got that one, good job. If you made a mistake, that's okay, but just make sure you figure out what you did wrong. Okay, so that was the class today. So let's get screenshots of all the work that we did today to help you with your homework or to study for tests. Here's screenshot number 1. And screenshot number 2. And screenshot number 3. And screenshot number 4. And screenshot number 5. And screenshot number 6. and screenshot number 7. So don't go before you get your homework. Let's take a look at the homework. So here's the homework. Get a screenshot of these first 2 pages and a screenshot of these last 2 pages. And remember, your homework has to have 4 characteristics. It has to be complete, correct, neat, and in correct chronological order in your binder. And if you don't do the homework, it's a 100% guarantee you're going to learn absolutely nothing in this entire course. Also, I want to remind you, you need to write your problem numbers and circle the numbers. And you need to rectangle all your answers and show the work that you need to show. And again, write your name, date, the course title, Intermediate Algebra, and you need to organize everything because this is a record of your work. So get that homework done, and I'll look forward to seeing you in the next class.